Look at this picture. ABCD is a cyclic quadrilateral and two of its angles are given. Angle A is equal to 75 degrees and angle B equals 100 degrees. We can easily find the measure of the other two angles. Since it is a cyclic quadrilateral, the opposite angles A and C are supplementary. Angle A is 75. So we have angle C equals 180 minus 75, that is 105 degrees. Similarly, angle B and angle D are opposite angles and they are supplementary. Since angle B is 100 degrees, angle D will be 80 degrees. Here is another one, a little tricky one. PQRS is a cyclic quadrilateral. Angle P is x degrees, angle Q is y degrees, angle R is 3x degrees and angle S is 5y degrees. Find the value of x and y. Okay, let's try to do it. We have the result that in cyclic quadrilaterals, opposite angles are supplementary. Now, whatever the measures of the angles, if you add them, you need to get 180 degrees. If you add the opposite angles. Angle P and angle R will give a sum of 180 degrees. The measures are x degrees and 3x degrees. So that means x plus 3x equals 180 degrees. Yes, you can add x and 3x, we get 4x equal to 180 degrees and x is equal to 180 divided by 4, 45 degrees. So the measure of x is 45 degrees and the measure of angle P is 45 degrees. Now in the same way, the other two opposite pairs, that is angle Q and angle S, give a sum of 180 degrees. Y plus 5y gives 180 degrees. From which 6y is 180 degrees and y is 180 divided by 6 is 30 degrees. So angle Q is 30 degrees. Now can you find the measure of all the angles in the figure? Angle P is 45 degrees, angle Q is 30 degrees, angle R is 3 times x. So 3 times 45, that is 135 degrees. Angle S is 5 times y, that is 5 times 30, 150 degrees. The angles of the quadrilateral are 45, 30, 135 and 150 degrees. Here is the next one. Circle A, B and C are points on the circle. Triangle ABC is an isosceles triangle. We have another point D next to A and a point E on the bottom part of the circle. All these are joined together. Angle ABC is 50 degrees. Can you name two cyclic quadrilaterals from the figure? We already know that cyclic quadrilaterals are quadrilaterals with 4 vertices on the circle. Look at our figure closely. Can you notice quadrilaterals in the figure? Yes, of course, we can see quadrilaterals. Can you notice quadrilaterals with its 4 vertices on the circle? Yes. Look at the points on the circle B, A, C and E. They join to form a quadrilateral. So, BACE is a cyclic quadrilateral. Take another one. BDCE. These 4 points join to form another cyclic quadrilateral. BDCE is another cyclic quadrilateral. So, the 2 cyclic quadrilaterals are BACE and BDCE. What is the measure of angle D? Looking at the figure, notice the 2 angles, angle A and angle D. Does it look familiar? Yes, children. In our last classes, we have studied about angles in the same arc. Angle A and angle D are 2 angles in the same arc, and so they are equal. All angles in same arc are equal. So angle A will be equal to angle D. Let us now try to find what is angle A. It's given in the question, triangle ABC is an isosceles triangle. Okay, so that means it has 2 angles equal. One of its angles is 50 degrees, and so the angle over there, that side, will also be 50 degrees. 50 and 50 together is 100, and so the third angle, angle A, will be 80 degrees. As we said before, angle D and angle A have the same measure because they are angles in the same arc, and so angle D will have a measure of 80 degrees. Next, what is the measure of angle BEC? We know about 2 cyclic quadrilaterals in the picture. And angle E, that is angle BEC, comes in both those cyclic quadrilaterals. We also know that opposite angles of a cyclic quadrilateral are supplementary. Let us consider any one of the cyclic quadrilaterals. BACE is a cyclic quadrilateral. BDCE is another cyclic quadrilateral, as seen from the first part of the question. Let's consider the cyclic quadrilateral BDCE. Which angle is opposite to angle E? Right, angle D is the opposite angle of angle E. We already know the measure of angle D. It is 80 degrees. Then what is the measure of angle E? Angle D and angle E are supplementary angles because they are opposite angles of a cyclic quadrilateral. So angle E will be 180 minus 80, that is 100 degrees. Let's check out another question. ABCD is cyclic. AB is the diameter of the circle. AD and CD are equal. AD equal to CD. And angle ADC is 130 degrees. What is the measure of angle ACB? take a look again at the picture. Angle ACB. Can you guess? Yes, AB is the diameter. And ACB, angle ACB, is the angle in a semicircle. We already know that angle in a semicircle is a right angle. That means angle ACB is 90 degrees. What is the measure of angle ABC? Well, I guess you have already found out the answer, children. Yes, ABCD is cyclic quadrilateral. So naturally, angle D and angle B are opposite angles, and their sum has to be 180 degrees. We already have angle D is equal to 130 degrees. And so, angle ABC will be 180 minus 130, that is 50 degrees. Let us find the measure of angle DCB. We already have a part of the angle. We already have angle ACB is 90 degrees. Now we need only to find out the other small angle to find the total angle DCB. Think about the triangle ADC. What kind of a triangle is triangle ADC? Yes, correct. We have a clue in the question. AD is equal to CD. So two sides are equal of that triangle. Means triangle ADC is isosceles. So we have the other two angles equal. One of the angles is already 130 degrees. The other two angles are equal. So 180 minus 130 gives us 50. 50 can be equally divided as 25 and 25. So angle DCA is 25 degrees. And angle ACB is 90 degrees, which gives us that angle DCB is 90 plus 25, that is 115 degrees. The last part of the question is, what is the measure of angle BAD? Again, ABCD is a cyclic quadrilateral, and as you have already guessed, children, angle A and angle C are supplementary. Just now, we have got that angle DCB is 115 degrees. So, angle BAD will be 180 minus 115, that is 65 degrees. Why don't you try to do the other questions in your textbook based on these results? Let us now come back to our earlier figure. We had a quadrilateral ABCD. Let us denote the angles by the small letters A and B and C and D. We have to draw the bisectors of each of the angles and mark their intersecting points. Look, I have drawn the bisector of angle A. Now, what is an angle bisector? It divides the angle into two equal halves. So, our angle A is split into half A and half A. Now, let's draw the bisector of angle B. Again, the angles are halved, half of B and half of B. Let us draw the bisector of angle C. We get two angles, C by 2 and C by 2. And the fourth bisector of angle D will give us half a D and half D. Now, P, Q, R and S are the points, meeting points of adjacent bisectors. We can prove something interesting in this. Let's consider the triangle DSA. It has three angles. One of its angle is half A, another angle is half D. So the third angle will be 180 minus half A plus half D. Consider angle PSR, the angle inside our small quadrilateral, angle PSR. Angle DSA and angle PSR are vertically opposite angles and they are equal. So we have angle PSR is equal to 180 minus half A plus half D. Similarly, look at the triangle CQB. Two of its angles are half C and half D. Then the angle CQB will be 180 minus half C plus half B. As said earlier, look at the angle PQR in the small quadrilateral PQRS. Angle CQB and angle PQR are vertically opposite angles and they are equal. Hence, we have angle PQR is equal to 180 minus half B plus half C. Now we consider the small inner quadrilateral PQRS and the two angles that we have just found out, angle PSR and angle PQR. They are opposite angles. Let's add these two angles. Angle PSR plus angle PQR equals 180 minus half A plus half D plus 180 minus half B plus half C, which gives us 360 minus half A plus half B plus half C plus half D. Now we had earlier said that A and B and C and D are the angles of the quadrilateral, of the outside quadrilateral ABCD. Well, a quadrilateral has 4 angles and their sum is 360 degrees. So the sum of the 4 angles of the big quadrilateral, that is A plus B plus C plus D, is 360. Then what about half of A plus half of B plus half of C plus half of D? Surely you take half of all the angles and the sum will be 180. Half of 360, that is 180. That is half A plus half B plus half C plus half D is 180. Now let's come to the continuation. 360 minus half A plus half B plus half C plus half D equals 360 minus 180. That is 180 degrees. Now what have we just seen? In the small quadrilateral PQRS, angle PSR plus angle PQR is 180 degrees. Or in other words, PSR and PQR are supplementary angles. Hence, the quadrilateral is cyclic. And therefore, a circle can be drawn with its 4 vertices on the circle. Now you know why the points P, Q, R and S were on the circle. Well children, now we have come to the end of our class today. See you next time, and don't forget to download the questions by Mr. John sir from our description box. Thank you.